Hello viewers, let us look at this NECO 2024 Chemistry OBJ question number 15. The question is really faulty because it has no answer. Before I continue to reveal why the question is faulty, if this is your first time of getting to see this channel, please click on follow button and save this video for reference. Now the question says equilibrium state is attained in a chemical reaction when concentration of reactants A and products are equal and products vary. There is no answer to this question. Now look at the reason. It's either the person that sits this question does not understand the true meaning of equilibrium, or there is a mix-up somewhere. Okay, let us now look at equilibrium state. The word equilibrium is gotten from the word equal, but looking at this equal, the word equilibrium could be deceptive. Now let's consider this meter rule and a very big mass here and a small mass here. If you want this system to be in equilibrium, you are going to shift the knife edge closer to where the bigger mass is. You can see the system is in equilibrium, but it doesn't necessarily mean that the two masses must be equal. No, they must not be equal, though there are instances where they are equal. Look at this equilibrium. If the knife edge is at the middle, then it implies that if you place 2 kg here, you will also place 2 kg here, provided that the distance from here to here and from here to here are equal. This is also a system in equilibrium. Consider this one, where you have a big mass here and a very small mass here. You know that the equilibrium position will shift to the right, right? Which means a system reaching equilibrium does not necessarily mean that what is at the left must be equal to what is at the right. I'm using this mechanical equilibrium as an instance. Now, what is now equal about this equilibrium? In these three systems, one thing is equal. It is moment of a force that is equal. Moment of a force means force times distance to the center. So the force of this mass multiplied by this distance must be equal to the force of this mass multiplied by this distance to the center. So these are the two things that are equal. The same thing here, from here to here and from here to here. The distances are not equal, the masses are not equal, but the moment must be equal. Now let's come to chemical equilibrium. In chemical equilibrium, the only factor that is equal is rate of forward reaction and rate of backward reaction. For instance, this is ammonia formation, where nitrogen reacts with hydrogen. For this reaction to be in equilibrium, the concentrations of the reactants and the product must not necessarily be equal. The only thing that will be equal is the rate of disappearance of these reactants, that is R1, rate of forward reaction, and rate of backward reaction, the rate of decomposition of this ammonia to form the reactants. So if these two rates are equal, then equilibrium is attained. There are a few conditions of equilibrium we must consider. Number one condition is that the system must be a closed system. Number two, I've mentioned it, equal rates of forward and backward reaction. Number three, no net change in temperature. The temperature is constant. Number four, no net change in pressure, especially for gaseous phase. Number five, no net change in pH. And number six, no net change in concentration of both reactants and products. The concentration of reactants may be 2 here and 1 here. Concentration of reactant may be 0.5 here and 5 here, yet the reaction will be in equilibrium. The concentrations may be equal, and yet the reaction is in equilibrium. So what we should be looking at is the equilibrium constant, which may be greater than 1. If Kc is greater than 1, it means that the equilibrium position shifts to the right, meaning that there are more concentration of the product than the reactant. Yet these concentrations are stable, no net change. If Kc is less than 1, it means that the equilibrium position has shifted to the left, favoring more production of reactants, meaning that the concentration of the reactant may be greater. If Kc is 1, it means equilibrium position lies at the middle, favoring equal concentrations of reactants and products, yet no net change in these concentrations. Now, going back to the question, you will see that the question is faulty. Equilibrium state is attained in a chemical reaction when concentration of reactant and products are equal. This is not a condition, because concentration of reactants and products may not necessarily be equal, yet the system is in equilibrium. And products varies. No, there is no variation. Instead, there is no net change in concentration. C, doubles the concentration of the product. This is possible, but it's not a condition. Is greater than the concentration of. This is possible, but it's not a condition for equilibrium. Is less than the concentration of the product. It's possible, but it's not a condition. It may be greater, it may be less, it may be equal, but all these are determined by the equilibrium constant. This now proves that this question is faulty and has no answer.